What do waves, complexes, segments, and intervals mean? In this lecture, we want to understand the language of the ECG. Before reading the ECG, we need to agree on the language of the ECG. The ECG is a continuous line, one unbroken line moving across the paper. But we've given specific names to specific parts of it, and those names aren't interchangeable. Wave, complex, segment, and interval. 4 different words with different meanings. And if you mix them up, you will misread what you're looking at and what you are expressing. So before we meet the waves individually, let's establish the vocabulary. Everything on the ECG is measured against one reference, the baseline. And the baseline is a flat horizontal line that appears when no net electrical activity is happening. The line sits still, neither up nor down. And it has another name, the isoelectric line. Iso meaning equal positive and negative forces, cancelling each other out, and the net result is 0. This is your reference point. Everything else is measured against it. The baseline is 0. Everything above it is considered a positive or an upward deflection, and everything below it is considered a negative or a downward deflection. The first structure we're going to learn in the ECG is the wave. The wave is a single deflection. The line moves away from baseline, upward or downward, and then returns. A wave means active electrical movement is happening. Electricity is traveling through the tissue, and the electrode is detecting it, and the paper is drawing it. And waves are named by letters. The P wave, the T wave, each one a single distinct deflection. One electrical event and one movement away from baseline. So, a wave equals one deflection. It means active electrical movement, and the line moves and returns. Sometimes several waves happen so rapidly and so close together that they can't be separated as individual events. They merge into one combined shape. That combined shape is called a complex. The only complex on a standard ECG is the QRS complex, and it contains up to 3 deflections: Q, R, and S waves. Happening in such rapid succession, they form one unified event. And here's something worth knowing now. Not every QRS complex contains all 3 components. Sometimes the Q is absent. Sometimes the S is absent. But in the end, it's still called the QRS complex, because that's the name of the event. So, a complex equals multiple waves merged into one combined shape, and the QRS is the only one in a standard ECG. Another important structure in the ECG is the segment. A segment is a flat stretch between 2 waves. The line returns to baseline and stays there. No deflection and no movement up or down. Just a flat line between 2 events. A segment represents a period where no net electrical movement is detectable. The electricity exists, but it's not producing a net force the electrode can measure. There are 2 main segments in a standard ECG. The PR segment, which is a flat stretch between the P wave and the Q wave of the QRS complex. And the second segment we have is the ST segment, which is a flat stretch between the S wave of the QRS complex and the T wave. The ST segment is the most important. In a normal ECG, it sits right on the baseline. When it rises or falls, that's one of the most critical findings in all of the ECG readings. But that's a hit. So, a segment equals always flat. It has no deflection, and the line sits on the baseline between two waves. An interval is a time measurement. It measures the total duration between two fixed points. It can contain waves, complexes, segments, or all of them inside it. And this is where people get confused. An interval isn't just a flat line. It's a time span. And what's inside that span doesn't have to be flat. Take the PR interval as an example. It measures from the start of the P wave to the start of the QRS complex. And inside that interval, the P wave and the PR segment are both included. A deflection and a flat stretch both inside one time measurement. Take another example, the QT interval. It starts from the start of the QRS complex to the end of the T wave. It contains the QRS complex, the ST segment, and the T wave, all inside one time measurement. An interval tells you how long something took, not what it looked like. So to summarize, an interval equals time measurement, and it can contain waves, complexes, and segments inside it. So the difference is simple. A segment is always flat, and an interval measures time, and may contain deflections inside it. They are not the same thing. Now let's walk through one complete heartbeat from start to finish using the vocab we just built. The line starts at baseline. Then the first deflection, a small upward wave, the P wave. And this is corresponding to atrial electrical activity. Then the line returns to baseline, a brief flat stretch, the PR segment. This corresponds to electricity pausing at the AV node. Then a sharp complex, 3 rapid deflections merging into one, the QRS complex, which corresponds to ventricular electrical activity, the biggest event on the ECG. Then back to baseline, another flat stretch, the ST segment, corresponding to the sustained contraction phase or the ventricles holding their charge. After that, a broad upward wave called the T wave, which corresponds to ventricular repolarization. Then back to baseline. One complete cycle, ready to repeat. So we have the P wave, the PR segment, the QRS complex, the ST segment, T wave. One heartbeat every time. So now we know the language of the ECG. The baseline is the reference everything is measured against. A wave is a single deflection corresponding to active electrical movement. A complex is multiple waves merged into one combined shape. A segment is a flat stretch between two waves. An interval is a time measurement across a phase of the cycle. From this point forward, every time we use one of these words, you'll know exactly what we mean. That's all. Thank you and see you in the next lecture.